Hello friends, in this video we will build a audio search engine, right? Uh, so the search engine, it will find, it takes an audio as an input and it will find similar audio files. Now the applications can be, we might want to find in a library all the audio files by a speaker, or we might want to find all the similar sounding songs so that we can build a song recommender system. Okay, so let's imagine we have a number of audio files here. Now, as you may know, we can represent an audio file as a vector, right? As a numpy array or a list. Now then we will use an embedding model which is trained on audio. So basically this embedding model, it convert the audio file into a high dimensional mathematical representation of the audio. Okay. So we apply this model and then we create these embeddings, are also known as vectors. So for each audio file, irrespective of its length, we will create an embedding. Now these embeddings we insert into a purpose-built vector database where we can search for similar vectors. Okay. Now these vectors are embeddings. They can be coming from text documents or images or audio files or video files. They can be anything, right? As long as we can convert a form of data into an embedding, then we can use this vector database to find a similar vectors, and these vectors we can map back to the original files. Okay, so in previous videos of this series, we have built two systems where we built a semantic search engine as well as a similar search engine. We also built another system which is to find out similar facial images. Okay, so the architecture is exactly the same. This time we would be using audio files instead of text files or images. Okay, and once we build the system, now let's say we have an audio file. We would like to find out all the audio files within this library which sound similar to this audio file, right? It could be the speaker, or it could be similar sounding audio files, so that we can build a audio recommender engine on top of it. Okay, all right. So we do the same. We apply the embedding model on our query audio, and we again get a vector, and we use this vector to query the vector database to find out the similar audio files, right? Similar vectors, and these vectors we map them back to the audio files. Okay, so that's the high level architecture which we have seen before. Now let me go to the pinecone. So as I said, we will be using pinecone for the vector database. Now you can register a free account and go to API key section and generate your API key. Okay, obviously because it is free version, there are some limitations, but for the demo purposes, it's all fine. Okay, and then you can create an experiment here. In free version, we can create only one experiment. I created my experiments called this project called my experiment, and I already run the code. So as you can see here, I have this database or index which is called this audio search demo. Okay, so here I have 2000 vectors, meaning I have already embedded or created embeddings for 2000 audio files and upserted those 2000 vectors into the database. And each vector dimension is 2048. Okay, so each audio file gets converted into a vector of size 2048. And then to find out the similar audio files, we are using this cosine metric. Okay, you can explore this UI further. It has lots of useful information about how, I mean, it's over time, how the number of vectors changed in this index, how we are making the requests, etc., right? And also we can do the operations like upset, querying the database, maybe updating some records or deleting the vectors, etc., from the UI also. Okay, so you can explore this later. Now, all right, view full screen. Yeah, yeah. Okay, all right. So now, so we need this library called this Panas inference, which is what we are going to use for creating the embeddings for the audio files. Now, these remaining libraries like pinecone client, the data sets, etc., we have installed in previous videos. And a new library, this Librosa, we will use to play the audio files. Okay. All right. So for this demo, we are going to use this dataset called ECS50. Okay. It contains some 2000 audio files, each with 5 seconds. Okay. I'll play one of the example audio files so that you can see. So here I have one of the files. So it's a vehicle starting sound, I mean accelerator. And here we have another audio file. It's birds. Hope you can hear that audio. And yeah, these are some of the audio files. So each audio file is of 5 seconds only. Okay. All right. So yeah. All right, so we load the dataset. It's this ECS50 dataset, and again, the dataset has train, test, and validation. For this demo purpose, we are only using the train dataset, which contain 2000 audio files. Okay. Now the data. Okay, here we are showing the first 3 records, and well, the actual data, it contains a couple of other variables like this file name, fold, target, category, etc., etc. But we are only interested in the audio section of this data, right? So we filtered it to audio, and then here we are showing the first 3 records. Okay. So the each record, it has this path, I mean, which we can ignore. The actual audio is in the form of this numpy array. Okay. So this one, and then we have this sampling rate. Okay. So here is the second audio file, and here we have the third audio file in the form of a numpy array, right? These arrays, we are going to use a AIML model which is trained on audio files to create the embeddings. Okay. All right. So again, from this one, we only need this numpy array, right? The audio file. We don't need the sampling rate, or we don't need the path. So we are just filtering further to have only the audio information. All right. And then we will be loading the embedding model to do the embeddings. So from this panels inference library, we are importing this module audio tagging, and that's the model we are going to use. Okay. Now I don't have this CUDA. I'm running this model locally, so we will be running on CPU. Okay, so that's why it's using CPU. Right now, this is the model checkpoint version. You can see. Yeah. So before creating the embeddings and inserting them into the index or database, we need to create it, right? So here I am importing Panda, a pinecone, and then I'm getting the pinecone API key and environment from my bash profile file, and we are initializing the pinecone. And then we'll create the database. So we give it a name. We are calling it audio search demo. That's what you saw on the UI. And we are making sure that this index does not exist already. And then, as we have seen in the previous videos, 3 sets of information is needed when we are creating a index in pinecone. So the first one is the index name, which is this, and then the dimension of vector. So we know this model is going to create vectors of size 2048, right? So that's why we are using the dimension as 2048. And then again, we are using this cosine similarity as in the previous videos to compute the similarity between different audio files or the vectors. So we create the index, and then we access the index, which is this audio search demo. Okay. And then we go over the audio files, and we create the embeddings and we insert them into the pinecone database. So again, due to the memory issues, we cannot insert all the vectors. We cannot compute embeddings for all the 2000 files at the same time. So what we do is we do in batches for efficiency. Okay, so we just choose a batch size of 64. So here we are choosing 64 audio files at a time. Okay, and yeah, these are the batch files, and then we are applying the embeddings. Okay, so this model is the model coming from this Panas inference library. Okay. And then here we are creating an ID because each vector needs to have an ID. And then here we prepare the data in the format the pinecone expects, the IDs and the embeddings. And finally, just commented this out because I was doing some tests, but this is where we are upsetting the vectors into the database. And finally, when you run this command, describe command, it shows the dimension of each vector and the total number of vectors. So this command was run before the data is inserted into the database. So that's why it is showing 0 vectors, but now it has 2000 vectors. So let me show you. Yep. So as you can see here, we have 2000 vectors in the database, which you can verify from here as well. So as you can see from here, we already have upserted 2000 vectors. All right. Okay, so we have built this part. We have built this top portion. We took 2000 audio files. We have chosen an embedding model designed for audio files. We have created the vectors and we have upserted those 2000 vectors into the database. Right, now comes to the application. So we'll have some sample audio files. Again, we apply the same model so that we can create the vectors of same size, which is this 2048. And then we use this vector to query the database to find out the similar files. Okay. All right. So here we are just picking up a random audio number. This happened to be some 4,400. And then we are just taking the array part, which is this audio, ignoring the sampling frequency and some other information we have. I think it's path. Yeah, so we have this path and we have the sampling rate, right? We are just selecting this array part, which actually contains the audio information. Okay. And yeah, so as we have seen here, this data set also contain the category of the audio, right? So for example, for this one, if we see the category, it's this car horn. Okay, that's the audio file. Now it should have shown this audio. Let me see. Yeah. Okay. So it's car horn. I'll play the audio. So as I mentioned, all these videos are 5 seconds. I hope you can hear the sound. It's a car horn. Okay. All right. So that's the car horn. Now what we do is we simply yeah. So here we are just taking we are reshaping the array, the NumPy array, and then here we are creating the embeddings, right? So we have creating the embeddings. So this size is 204, and then this is where we are querying the pinecone database. Okay, so this index is referring to the database we created, audio search demo, and we are searching with this embeddings we just created, which is this car horn. Okay, and we want 3 vectors back, or 3 similar audio files back. Okay, let me run this again. Okay, so here we have 3 files along with these IDs and their scores. So the score is close to 0.9 for all these 3 files, which is good. Okay, and then let's play the audios. Okay, so here we have those 3 audios. Now ideally these three files should sound similar to the car horn which we have heard from this file. Okay, let me play one file. Okay, that looks car horn. Yeah, another one. Yeah, that looks good. Okay, and here so we write a helper function so that we don't have to do in these multiple cells, right? Here we did uh, here we took an audio file, we took the audio part of the file, and then we have created the embeddings, and then we have queried the database, and then we play the audio files, right? So these four things we are going to wrap in a function so that it becomes convenient and we can test the database on multiple files, okay, which is what we are doing here. So we are simply going to supply an ID. So using the ID, we are going to read the audio file, and then we are going to display or play the audio file, I mean the test audio file, and then we are going to query the database for 5 similar records, okay, and then we have the results and we are playing those results here, okay. So this is our test audio file. Let's see what it is. Okay, it's a car horn. It's the same file, I think it's the same ID, right? It's the same ID. Let me see. Okay, it's a different ID, but this also happened to be car horn. Oh, sorry, it's not car horn. It's this motor vehicle acceleration, right? So as you can see, these audios are very similar. And then here we have another a query file. So we are simply supplying the audio. So using this audio, we will find using this ID, we will find the audio, and then we'll get the audio part of it from NumPy array, and then create the embeddings, search the pinecone database, and get the 5 results, and we are playing the 5 results here, okay. So this is some birds chirping. Let me see. Okay, that looks good. That's also bird. Yeah, same birds making. Okay, that's looking good. Yeah, so we have these 5 also sound very similar to our query file, right? And again, the query file, it don't have to come from the database or or the files we have. So here we are downloading a different file from the internet. Okay, it's a different file from the internet, and so we use Librosa just to play the audio file. So let me see. So as you can see, so this file is 6 seconds, right? In our database, all the files are just 5 seconds. But that's okay. It doesn't matter whether it's for text files or image files or audio files or any form, irrespective of the input size, the output or the embedding vector going to be fixed dimension determined by the model. Okay. So this 6 seconds audio file is also going to be converted into this 2048 size vector. Okay. All right. So we are doing exactly the same, but this time because we cannot use the helper function because this is the file downloaded from the internet. So what we did is we just took the audio part of the file, and then we are creating the embeddings, and we are searching the database. And this time we are asking only for 3 files. Okay. So let's see. Yeah, this sound is similar to the file we downloaded from the internet. Okay, so that's how, I mean, if you want, you can delete the database or index using this file. Okay, so using this function delete index, and you simply supply the index name. That's all for the today. But as you saw, the process is very similar, whether it is text or image or audio or maybe another form of data. What we do, the process is very similar. So we take the files, we choose an appropriate embedding model, we convert the data into vectors, and we upload them into the vector database. That's how we build the application. And then for using it, we'll have a query file, which can be again text, image, or audio. We apply the same embedding model so that we get a vector of same dimension, and we will use this vector to query the database and to get the IDs, and the IDs we can map to the files. Okay. Yeah, that's all for this video. Thank you very much.